Hello everyone, this is Chang Lao and I am your presenter on BiToolkits for MicroStrategy. In this session, we will take an in-depth study on dependence and component search in BiToolkits. The dependence and component search functions are essential tools for change impact analysis, so it is beneficial to learn how to use these tools effectively. We will cover both concepts as well as usage on these tools. We will be in demo mode for most of the session. We will start with hierarchy level in recursive search and then on to the rest of the functions in sequence listed here. For this demo, we will use MicroStrategy's Enterprise Manager project. We will use BiToolkits Pro version for this demo, as features discussed here are not available in the free version. Let's start the demo. Let's perform a recursive dependence search. Let's go to the Change Impact Analysis tool. Click the Object Finder. Let's enter User Analysis Document Cache Hit Filter and call this batch Demo 1. Click Search. Find the filter. Select the filter. Make sure Nested Levels checkbox is selected, otherwise it will perform a single level search. Click the Dependence Search button. 4 objects returned. Notice the Hierarchy button. It is a toggle button. Click on, click off, and click on. When we perform a recursive object search, the returned objects are tagged with a number indicating at which recursive level the objects were found. This enables us to view objects by their recursive hierarchy level. There are 3 recursive hierarchy levels on display. Level 0 is the source object, User Analysis Document Cache Hit Filter. It is highlighted in green color. Level 1 is a metric. Level 2 is a grid report. Level 3 is a document report. So the recursive hierarchy level guides us stepping through the object dependency chain. The filter is used in the metric. The metric is used in the grid report. The grid report is used in the document. Let's try another recursive dependence search. Go to Object Finder. Let's enter all tables. Let's name this new batch Demo 2. Click Search. Find the filter. Now select the filter. Make sure Nested Level is checked and click the Dependence Search. 13 objects returned. They are nested in 4 recursive hierarchy levels. Here's a question. Do we know which of the level 0 to level 3 objects are used in the level 4 objects? From this search, we cannot tell. In a bit, we will introduce the parent-child viewer function, which can be used to answer this question. Let's try a recursive components search. Let's go to Object Finder. Let's look for the phrase report usage and call this Demo 3. Now click the Search button. Find 3 objects. Notice the Object Finder uses partial string match on all text searches. Now select the Report Usage Analysis document. Make sure the nested levels is checked and click the Components Search button. This document report contains 259 objects nested in 5 levels. I hope you find this recursive hierarchy level button useful. Before we move on to the next demo, I would like to clarify one thing. What if an object is used by multiple objects in different recursive hierarchy level? Should we display the same object multiple times in a different level? If we do, we will end up with duplicate objects in the result set. To avoid duplicates, we employ the following logic. In components search, it picks the highest level, which means the object is tagged with the smaller recursive hierarchy level number. In dependence search, it picks the lowest level, which means the object is tagged with the bigger recursive hierarchy level number. Our next demo is the parent-child viewer. We're going to search by object IDs. Notice this text contains 4 object IDs. BiToolkits is smart enough to parse them out. Let's call this Demo 4. Click the search button. Found the 4 objects. Let's select them all and click the Dependents search button. Notice the parent-child viewer pops up. Let's move this window down. This viewer allows us to view dependent objects on each of the 4 source objects we selected. Notice the object count column: 7, 29, 16, 1. The search results here are organized into parent-child relationship. The source objects are their parents, and the dependents are their childs. Notice the green background color indicates this is a parent object. If the parent object is in red color, this means it has no child objects. If we close the viewer, it will combine all childs from the 4 parent objects and show them together here. The combined total is 43. Notice the numbers don't add up. 7 plus 29 plus 16 plus 1 equals 53. That is because duplicate objects are not displayed here. If we click the parent-child viewer again, the grid only shows the childs per individual parent. What if we want to see all the 4 parents and what they have in common? Click the first parent and hold down the Shift key and click the last parent to highlight all 4 objects. Then click the Common Childs button. The grid will show no child objects. This is because the RP request state metric has no dependence. What if we want to see the first 2 parents and what they have in common? Click the first parent and hold down the Control key and click the second parent. Then click the Common Childs button. 2 child objects are showing: a grid report and a document report. What if we want to see the 2 attribute parents and what they have in common? Click the first attribute and hold down the Control key and click the second attribute. Then click the Common Childs button. The grid shows 6 objects that are common dependents on these 2 attributes. Notice the DB connection attribute has 16 child objects. What if we want to know whether any of these 16 child objects are also child objects of the other 3 parent objects? Let's select all. I want to draw your attention to this object here. 71 Summary of Configuration Objects Report. Now when I click the All Events Parent Object, notice the checkbox on the 71 Summary of Configuration Objects Report. This is the common child object between these 2 parents. There are 4 common child objects between these 2 parents. 1, 2, 3, 4. I want to draw your attention to the count column here. Now watch when I tick the Restricted Childs checkbox. The count changed to 4, 6, 16, 0. 4, 6, 16, 0. This is the count of selected child objects. Now untick the Restrict Childs checkbox. The count changed back to 7, 29, 16, and 1. Tick the Restrict Childs checkbox again. The count changed to 4, 6, 16, 0. Now watch what happened when I tick the Restrict Parents checkbox. Notice the RP request state metric got dropped out. This is due to the child count is 0. Let's see again. Untick, tick. Watch what happened when I untick the Restrict Childs checkbox. Notice the grid shows all childs for this parent, but the count remains the same, the count of selected child objects. Now untick the Restrict Parents checkbox. Notice the count changed to count all objects. So the Restrict Parents checkbox controls the parent object display. If it is checked, The parent object is displayed only if one of its child objects is selected. If no child objects are selected, the parent object will not be displayed. If it is unchecked, all parent objects are displayed. The Restrict Childs checkbox controls the child object display. If it is checked, the child object is displayed only if it is selected. If no child objects are selected, the display will be empty. If it is unchecked, all child objects are displayed. Notice the child object count shows the selection count only if either of the Restrict Parents checkbox is checked or the Restrict Childs checkbox is checked. Otherwise, it shows the count of all child objects. Remember in Demo 2, we posed a question whether we know which of the level 0 to level 3 objects are used in the level 4 objects. Let's work on this. Let's select Demo 2 batch. Let's toggle the hierarchy view. Before we start, let's copy the object IDs that we need to use in later steps. I go to Batch Manipulation tab and click the Copy to Clipboard button. Now objects are copied to the clipboard. To show you what's copied in the clipboard, these are the object IDs that we copy to the clipboard. Now we're going to select the level 4 objects. Let's clear all the selections and select level 4 objects. Now click the Components Search button. Make sure Nested Levels is selected. Let's close the parent-child viewer for now. Notice there are combined 583 components from the level 4 objects. Now we need to select the components that are level 0 to level 3 objects. We're going to paste the object ID from the clipboard. Go back to Batch Manipulation and click the Paste button. Notice 9 components are selected. These 9 components whose object ID matched with the object IDs stored in the clipboard. Open Parent-Child Viewer again. Move it down. Tick the Restrict Childs checkbox. The count shows the number of objects from level 0 to level 3 is used in this level 4 object. 5, 5, 4. So we have answered the question which of the level 0 to level 3 objects is used in the level 4 object. Now suppose you want to export the parent-child objects to Excel. Tick the Restrict Childs checkbox. Select all parents. Click the Export button. You have the option to click Yes to export parent objects and selected child objects, or click No to export parent objects only. We click Yes. Now it asks to select an output format. There are numerous formats to choose from. We select the first one, which is Excel. Click OK. Now it prompts me to select a folder to save. We just save to the default folder. The file is saved and also automatically opened in Excel. Notice the parent object and their selected child objects is saved in each row. The export file contains some very useful details. Let's go over them. Start with parent name, parent object ID, parent object type, child object name, child object type. The rest of these fields are pertaining to child objects. The child object owner, folder path. You can see it more here. Object update time. This can be formatted to show the time. And the object ID. Now let's close the Excel. Now suppose we want to copy these report selections from the parent-child viewer to the Change Impact Analysis screen for further actions. We already have this report selected in the parent-child viewer. All we need to do is click Save and Exit. We got an alert indicating existing child object selections will be overwritten by parent object selections. Click OK to continue. Now the parent object selections are copied over. We can view this by sorting the selection checkbox. We can perform further actions on these selections, such as compare them against another project, rename them, create command manager scripts, etc. The last thing I want to show is the Options tab. There are 3 options, and they only apply to components search results: maximum details, medium details, or minimum details. Let's try components search. Let's enter all tables and call this demo 5. Find the object, select it, and do a component search. Make sure the nested levels is checked. Notice 16 objects returned. It includes column and logical table object types. Let's try minimum details. Select the filter and click component search. It returns only 2 objects, excluding column and logical table object types. Let's try maximum details. Select the filter and click the components search. 30 objects returned, including function, attribute form, column, and logical table. This concludes our session. As we have demonstrated, the dependence and component search tools are powerful and flexible. These tools are essential for change impact analysis. And features discussed here are only available in the Pro version. They are not available in the free version. There are many productivity tools built into BiToolkits. In subsequent sessions, we will show you how to effectively use various tools in BiToolkits to increase productivity. In next session, we'll demonstrate the web subscription cloning tool in BiToolkits. This is a highly praised feature in BiToolkits. It allows you to create hundreds of web subscriptions with the click of a button.